To the determinant of a matrix, the inverse matrix only exists if we are talking about a square matrix. Alright, so just to recap, a square matrix is a matrix with order 1 by 1 or 2 by 2 or order 3 by 3. Okay, so again, we don't usually concern ourselves with order 3 by 3 or 1 by 1, so it'll be usually this. Okay, so we don't have to worry about that. So how to find the inverse of a matrix then? Well, this is the formula. Okay, so let's say we have a matrix A, which is a 2 by 2 matrix. Okay, and we have A, B, C, D. Okay, the inverse of A, which is denoted by A, sort of looks like to the power of -1, but bear in mind that in matrix we don't think of it this way. That's it's 1 over A. Okay, so this is absolutely wrong, incorrect. Okay, so bear in mind. All right, this is not algebra anymore. This is in matrix system. So the inverse of A, alright, will be found if we have 1 over the determinant of A, alright, multiplied by, okay, a rearrangement of the original matrix. Okay, and this rearrangement is rather interesting, isn't it? Let's take a look. Okay, so what we have here is that the A and D swap places. Okay, and that the C and D, the B and C, okay, remain at the same place, but now they become negative. Okay, so let's take a look at how it works. Now, say we have a matrix B, okay, 1, 0, 5, 4, okay, and we are interested in finding the inverse of matrix B. Okay, so how do we do it? Well, the first thing we do is that, of course, we need to find out what is the determinant of B, isn't it? Okay, so the determinant of B will be simply 1 multiplied by 4, alright, and then minus of 5 multiplied by 0, so it's AD minus BC, so this will give us a 4. Okay, and according to the formula anyway, so our inverse of matrix B will be simply 1 over 4, okay, multiplied by, now the A and the B will swap places, so A and D will swap places, so 1 4 becomes 4 1. Okay, now 0, negative 0 is still a 0, but here this will be a negative 5. Okay, so here we go. This is our inverse of B. Now you may choose to multiply in the 1/4, okay, of which you will get this result. Okay, so it doesn't matter, alright, whether or not you multiply in the constant. Okay, now let's take a look at the next one. But before that, we have to scroll down. Alright, now we have a matrix C now. Okay, 1 3 2 6. Alright, so we're again interested to find the inverse of C. Okay, so the first thing we do is, of course, as usual, we have to figure out the determinant of C. Okay, so the determinant of C will be 1 multiplied by 6, that will give us a 6, minus of 3 multiplied by 2, which will give us a 6 as well. So that will give us a big fat 0. Okay, now, what you must then realize is this. Since we are going to find the inverse of C, therefore, inverse of C will be equal to 1 over the determinant, which will give us 1 over 0. Okay, it doesn't matter what you multiply by anymore, because 1 over 0 spells trouble. Okay, because we cannot have a 0 as the denominator. Okay, it is no such number. There's no such number, is infinity. Okay, so what we can conclude from this is that, well, there is no inverse for C. Okay, so whenever the determinant is equal to 0 of any square matrix, the determinant is 0. Okay, we say that there is no inverse for this matrix. For matrices without inverse, they are also known as singular matrix. Okay, so whenever the question tells you that the matrix is a singular matrix, you know what they're talking about. Simply to tell you that there is no inverse for this matrix, and not only that, you also know that the determinant of that matrix in particular will be 0. Okay. Alright, so now you have learned quite a bit about the inverse of a matrix. Now, what is the property of the inverse of a matrix? Well, basically, say similar to our functions as we learn them, alright, inverse matrix does something rather interesting as well, is that they cancel out each other. Okay, so when you have matrix A multiplied by the inverse of A, we will get I. Okay, it sort of cancel out each other. So what you may want to think about it is this, that for matrices in the matrix system, alright, there is only multiplication and no division, isn't it? Okay, so you can think of it as this functions more or less like a division type of function. Okay, so anyway, to avoid confusion, this is the only thing you really need to know. Okay, so A multiplied by A inverse is equal to I, or A inverse multiplied by A will give you I. Okay, so again, for special cases like this, these multiplications are commutative. Okay, but in general they are not. Okay, as we mentioned earlier on as well. So this is now. So whenever you have a pair of matrix, so B multiplied by C is equal to I. Okay, so what you can conclude is that, well, is C is the inverse of B. Alternatively, B is the inverse of C. Okay, so this kind of relationship, alright, must exist so that the multiplication will be your I. Okay, so this is something that you have to bear in mind as you proceed along.